This ODE is an autonomous differential equation because the right-hand side here depends only on P. It doesn't depend directly on T. So as we've seen before, autonomous ODEs have this particular type of direction field. So for any P value, the slopes are all the same for any T. So if we draw the direction field here, P against T, so if we pick a value of P here, the slopes throughout this line, they will be all the same. If the slope is 1, let's say if slope is 1, then it will be 1 throughout this line. All the slopes will be 1. So we can draw the phase portrait of this ODE, right? So all we have to do is to find, so we find first the critical points or critical values, right? So we can set the right-hand side equals to 0. So let's go ahead and do that. So we set P A P minus B equals to 0 because we want to know when the derivative is 0, right? So we set the right-hand side equals to 0 to figure out where are the slopes that are 0. Well, when we do this, then we get two solutions. Either P is 0 or AP minus B is 0, which means that P is B over A. So here are the two critical points. So let's put those in there. P equals 0 would be right here. So on the T line. Okay. And P equals B over A. B and A are positive. So when you divide two positive numbers, you get a positive number. So let's say it's right over here. So let's put that here. So all the slopes along this line here are 0. And all the slopes here are 0. So that means that in those regions, in the region between the two those two lines, in the region above this top line and the region below that bottom line, the derivatives are either positive or negative. So all I have to do here is to figure out what is the sign of the derivative in here. Are the derivatives here positive? Are the derivatives here negative? Let's find that out. So it has to be a point. It has to be P between 0 and B over A. So let's see what happens then. Suppose P is a value between 0 and B over A. Well, if that happens, then look at this expression here, AP minus B. Is that positive or negative? We know that P here is positive, and AP minus B, would that be positive or negative? Well, see, if this is the case, if we multiply both sides here by A is positive, so we can do that, and the inequality sign doesn't change. So that means AP is less than B. If AP is less than B, then when you subtract, this expression becomes negative. This is negative and this is positive. So the whole thing here is negative. Okay, so that means the derivative. So if you look at the derivative here, see that is dp dt dp dt, which is PAP minus B. This will be negative, right? Because P is positive and AP minus B is negative. So we know that in this region here, the derivatives are negative. So that means the slopes there are all negative. So instead of drawing the whole direction field, we could simply draw the phase portrait. Right? So that's why in the book they reference phase portraits like this. And so here is B over A, here is 0, and we know the derivative here is 0. Okay. Now let's look at the region above B over A. If P is greater than B over A, let's try that. then this means that AP is greater than B, right? So AP here is greater, well here, AP is greater than B, so this expression is positive, and P is also positive, so the whole thing is positive. So that means that here, right, the derivatives are positive. So B over A is a critical point, and so that's a repeller, right? We call it a repeller. Let's take a look at down here when P is less than 0 over here. So if P is less than 0, well, then it's less than B over A, right? Because if P is here now, then it's less than 0 and it's also less than B over A. Let's see what happens to the sign. So that means AP is still less than B, right? It will multiply both sides by A. A is positive. Multiply both sides by A becomes AP less than B. So this means that the derivative is what? Let's take a look. AP minus B. So P is negative. And AP minus B is also negative, right? Because AP is less than B. So here we have negative times negative, that becomes positive. Right. So that will show here in the phase portrait, it will show the arrow going up, right? If you want to look at the direction field, then the slopes are like this. Okay. Now we can answer the question. If we go back here, discuss what happens to the population as population P as time increases. Well, then you have several questions, and I'll let you write those down. It depends on where your population starts. So if your population, see, T equals 0 is in the initial population. If the initial population is between 0 and B over A, then what's going to happen? Let's say the initial population is here. The population will start to decrease because the slopes here are negative. So the population will go down until it reaches this equilibrium point, right? The slopes here are 0. So it looks like if this is a differential equation describing population, that means we start with initial population and the population is decreasing. So this could be a situation where there's some kind of disease and the population is dying, right? Now, the population cannot be in here, right? You couldn't have population here. That means negative population. In terms of, if we look at the model, negative population doesn't make sense. So, but mathematically, if you want to say that P is less than 0, then what's going to happen is the solution here will go up, will grow, and we'll reach this equilibrium point. Okay. And what happens if the initial population is greater than B over A? Then the population is going to keep growing forever, right? It's going to go up. Because look at the phase portrait, the derivatives there are positive. And I could have drawn the slopes here. The slopes there are positive. So that means here the population will grow. So to answer the question in this exercise, discuss what happens to the population P. Well, you can say case number 1, if the initial population is greater than B over A, then the population will grow, will keep growing to infinity. If the initial population is between 0 and B over A, the population will die down towards 0, will get closer and closer to 0 as time goes on. If the initial population is negative, then the population will grow until it reaches, it gets closer and closer to 0.